by email or stay when the class is over, okay? Okay, guys, let me explain something. This class, similar to the other mini term, is very, very, very intensive. Intensive means que go fast because it's in a week. And also, college algebra is more complicated. So go fast and complicated together is very, very hard. Okay? Some people, my experience is, I teach in 10,000 times this class. And I can see that some students fail that class because it's hard. Entonces, my recommendation is try to don't be absent any lecture. The lecture that maybe you are absent, I will post it in Blackboard. So when I record the video, by the way, I forgot to record a video. No, somebody help me to record a video. Okay, I appreciate so much. You press the button here, record. In this case, a red color, so it's recording. Okay. I posted the video in Blackboard of the Miami-Dade College, and also I posted in YouTube in my channel. Don't worry, because when the class is over, I will send the link connected with this, okay? And you try to find it easy. So let me explain. Basically, we have 4 chapters, 4 tests. Chapter 1, Chapter 2, Chapter 3, and Chapter 4. And the chapter, in each chapter, we have 2 tests. One test, number 1, no? Because the chapter 1, I call on paper. This test, I will send to you by email. Okay, when according to the syllabus, I can see here October 30 is the day for the first test. This day, October 30, I will send the document in PDF of the test. But I collect, so this is due. It's due November 2nd. November 2nd, que es the next day, next day, que, okay, let me see in the calendar, for example, to make sure, very, very clear, it is precisely the idea. October 30 is Friday, no? It is Friday. And November 2nd is next Monday. So we have the entire weekend for doing this test. When you finish the test, you write on paper. You try to convert to electronic or digital format, no? Maybe take a picture, maybe using a scanner, and send me back by email. This is by email, always email, by email. But we have another test. Okay, each chapter contains 2 tests, on paper and online. Test 1 again, online. Online is using Alex. Alex is a software. It's totally online. You need to buy Alex. You need to spend money with the Alex. No book, guys. Only you need to purchase a code, a class code. The class code is available in the bookstore of the Haunted Campus. Okay, so you don't know exactly how you communicate with them, I try to find. When you communicate and you purchase online, purchase in the campus, no? The campus. Or some people can prefer you can buy online. I hear some students told me in the campus is cheaper. Sorry, online is cheaper. But online you need to use your own money And in the campus, maybe you have financial aid. Okay, this is your option. Entonces, my recommendation is as soon as possible, you buy the code and you create account. Okay, let me show you. Let me show you first. Let me see. The student of continuation know very well exactly I am talking now. But the rest, look, this is Alex. Let me switch in the window to Alex. Do you see? Do you see Alex? Entonces you open your
Yes, sir.
Yes.
you open your everyone is familiar with the Alex you were before or no? No, maybe the student
This
of
is the first
continuation.
time.
It's the first time. Okay, no problem, no problem. This is super easy. This is super easy. You go to the www.ale.com. You are a new student, so you click in the yellow part because you are a new student, and you create your account. Fill out the form, first name, last name, email address. Okay, I recommend you using the email of the Miami-Dade College, no? And you create an account. And when you create an account, in the assignment, you go to the assignment, and the assignment is waiting for you. Let me see. In this moment, it's waiting for you. Two homework. So the organization is. Let me come back to the whiteboard, guy, to explain this idea. Okay, whiteboard. Okay, boom, boom. Okay, whiteboard. Look at that. Actually, we have two homework. Okay, two homework. We have one pretest and the official test. Okay. The homework is for practice. It's complete option. The pretest is like a practice for the test because I guarantee you the same topic that you can see in the pretest is similar, very, very similar to the test. So my recommendation is do the homework, and when you are doing the homework, any question you have about the homework, you communicate with me through email. You, for example, professor, do for me the question number 2. You took a picture and send me my email the picture. Okay, because remember you say number 2 is a no complete information because when you open number 2 in your platform, it's different to number 2 in my platform, and it's different to number 2 in another students. It's the but it's different number. Entonces, si you want que I help you efficiency, you take a picture, send me back the picture. I solving the problem in 5 seconds. I reply. Anytime, any day, don't hesitate. I'm your friend. Okay? Now, take the pretest. When you feel strong, because you understand the pretest you can take infinity time, the unlimited time. 1, 2, 3, 4, 20, 30, 1,000 times. But the test, no. The test is only 2 attendance. Okay? I select the higher score in between 2. Okay? Suppose in the first you get 70 point, and the second you get 95, your grade is 95. Entonces, this is exactly the same chapter by chapter. The same routine, the same chapter 1, chapter 2, chapter 3, chapter 4, the same. Test on paper and test online. I forgot something. Let me finish, please. Victoria Ferrer, okay? The homework is optional, but if you get in both homework more than 80%, you have 10 additional points extra, like extra bonus, like extra credit. Suppose in the test you get 95, 95 plus 10, because you finished the homework, 105, A plus. Okay? Let me see what more information, important test. Well, of course, in the test, is you are doing at home, no? You can use a calculator. I don't care the arithmetic part. I care the algebra part. Well, open. Any question? Activate the microphone, please.
No, you just answered it. I wanted to know if the homework was worth a grade.
Good. Don't hesitate. You ask me anytime you forgot something, you ask me again. But not in the lecture. The lecture I want to discuss in mathematics. Too much. You email me. Okay. This is online class. Do you understand that? It's remotely, no? So you have to check in every day the email. No, you are lost. No. Okay. We have a calendar, we have a schedule, and you follow me. Open the email every day. Every day you open the email. Okay? I understand at the beginning, in the first week, we have some delay. But as soon as possible, you try to open Alex. Alex is extremely important. Open Alex, create account, and start working in the homework. Any question, we communicate with me. Okay? Any question? Well, the student of continuation very well know my way, no? Explain. It's just a continuation, different topic, no, different algebra, but it's the same. The new student very well understand very well or no?
Yes.
Okay.
Yes, sir.
Okay. So I warning guy, this class is hard, very hard. For example, some students need to take 3 times. Presuppose que no, because it's hard. I forgot to explain one more thing. Do you see the board? What about final test?
Yes, sir.
What about final test? What about final test? Totally optional again. So you don't need to take. Suppose one excellent student can get 100, 95, 90, 100 again. When the average this is 8. You don't need to take the final. No final. Well, suppose that one student failed one test, 50. Entonces, therefore, maybe you have C or B or D, no? Entonces, you need to take the final in order to improve. So, for example, the grade for the final replace. Suppose in the final you get 80, and this 80 replace this 50. Yeah, average again. Maybe you get B. Okay, so the final no mandatory. The last day you say, well, your overall grade is B. You agree or disagree? No, for me it's perfect. Okay, so you don't need to take final. Final is only to improve, to help the student to improve your grade. Clear? Crystal clear?
Crystal
clear?
I have a question.
Please.
If we get a lower score on the final, can we keep the average or do we have to keep the final score?
Yeah. Good question. Excellent question. Yes, suppose you fail the final, you keep the same. So I highly recommend to take the final because only you go up, never down. Okay? Good question. And by the way, final is so one advantage and one disadvantage. The final is community. Community means everything together, every chapter together. Wow, no good, right? But it's multiple choice. It's multiple choice. The final. The rest of the test, I forgot to say that, you have to show me your work in detail. Okay, in the piece of paper, you show me your work in detail. Okay, I want to see the algebra. You get this answer, but where come from this answer? Okay? Okay? And the final is multiple choice. Entonces, I can erase the board or no? Yes. Okay, today we start the first topic is relatively easy. It's about complex number. It's a very, very important. Complex numbers. Let me try to understand complex number. Suppose I want to compute square root negative 25. It's obvious that this have no real solution. I want to explain why. Look, this is my old real number line. This is infinity positive. This is infinity negative. This is 0 in the middle. And you have to remember the definition of the square root. When you find the square root, you need to find one number que multiply by itself. Give me the number inside the radical, que es, in our example, negative 25. Suppose que I select negative 5. Well, negative 5 times itself is positive 25. No, negative 25 is the number that we need. And of course, positive doesn't work because 5 times 5 is 25, no negative 25. In conclusion, this statement, no real solution, means that the solution of this computation is not on this line. It's in another dimension, in another planet, in another place. Okay? Entonces, to solve that problem, mathematicians create, by definition, que square root negative 1, they call I. It's a definition. That's it. So for solving any problem, let's come back to the square root negative 25. The square root negative 25, you solve it in that way. You break it down like a square root positive 25 times square root negative 1. And square root positive 25, of course, is 5. And by definition, square root negative 1 is I. So the answer is 5i. And this no new number que contain I is called imaginary number. Okay, so we have the traditional real number que don't contain I, 5, like that, 5, 6, 7. It's a real number, real. This is the real line, real numbers. And we have now a new number que is called imaginary number. It's a number que contain I. Que living in another line, in the imaginary line. It's not important now where it's located. Okay? Let me try. Entonces, what is the fantastic conclusion? Well, the fantastic conclusion is, in general, a square root negative any number is equal square root the same number but positive multiplication by I. This is the formula. Suppose another example. I call example 1. Square root negative 200 is equal square root positive 200 multiplication by I. Leave it like that, no? No, because I know okay, we can simplification 200 is 2 and 100. And square root 110. And the answer is 10i radical 2. You can write like that. Clear? Any question, guy? Do you remember very well this in high school, no? Or no?
Yes.
Yes. Everyone remember, no? Okay. Today is our day to the complex number. Suppose typical question in the test. Example 2 now. Example 2. Square root negative 9 times square root negative 9. Compute that, please. Well, square root negative 9, let me try to do separately here. It is square root positive 9 multiplication by I, and square root 9 is 3. That's 3I. And the answer of this is 3I. And the answer of this is identical because it's the same, it's 3I, another 3I. And 3I times 3I is 9I squared. Oh, look at that, I squared. I squared, unbelievable, but it's not imaginary, it's real. This is real.
Equal 1?
Equal negative 1. Equal negative 1. Negative 1. Let me explain why. Let me explain why. See, by definition, you know that I is a square root negative 1. If you square both I square, entonces in the right-hand side, we have power 2 and a square root. They cancel out, disappear, this and this. It's negative 1. So be careful. I is imaginary. But I square, no, it's real. The I square is located here, look. 1, negative 1, here. This is a negative 1. It actually is I squared. Entonces this is complicated because sometimes depending on the power, si the power is even, exponent is real. Si the power is odd, it's imaginary. Pero no, let's see in detail now. No, now. Let's continue. For example, example number 3 is square root negative 64 times square root negative 25. Let me take advantage to explain one typical mistake. Okay, some student doing that problem or try to do that problem in different way. Look at that. Some students say, well, professor, I can join, put together this radical and this radical. So I multiply negative 9 and negative 9. Entonces, negative 9 and negative 9 is 81. And the square root 81 is 9. Oh, but the answer is 9I squared. Okay, actually, I forgot to say, sorry, it's negative 9 because I squared is negative 1. So the answer is negative 9. So this is wrong. Conclusion. When you see a square root and inside we have negative number, we cannot join radical. This is totally incorrect. That we compute separately. Because a square root negative quantity is imaginary. Okay? Likewise, example 3 is a square root 64, que es 8i. Multiplication, square root 25, que I did before, fi. 40, I square, que I square es negative 1, entonces minus 4. The answer is negative 4. Super. Any question?
Yes, sir. Yes,
No
sir.
problema. Okay, example 4. Example 4 is a little bit more complicated. Square root negative 16 times square root negative 4 times 3. Square root negative 49. Entonces I can see negative number inside the square root. What is it? It's 4i. The first is 4i, no?
Yeah.
The second, 2i, no?
Yeah.
And the last one is 7i, no?
7, yeah.
And you multiply 4 times 2 is 8 times 7 is 56. I cubic. Because we have 3i, no? 1, 2, 3i. What about I cubic? I cubic in my mind is like I squared times 1i. Yes or no? I to the 1 power, no?
Yeah, it's going to be positive.
And this guy is negative 1. It's negative I. Wow, look at that. Let me copy this idea. I alone is high. I high. But I square is negative 1. Yeah, I cubic is negative I. This is like alternating. Power 1 is imaginary. Power 2 is real. Power 3 is imaginary. I suppose I predict the power 4 is real, to be real. I don't know. Okay, so what is the final answer here? The final answer is 56 IQ. No, well, no, this is correct. but more elegant is negative 56i because I know que I cubic is negative I. Okay? Okay? One more example of the multiple radical and inside negative number, right? Example 5 is a square root negative 36 times square root negative 81 times square root negative 16 times square root negative 9. You compute one by one separately. This is 6i.
6.
This is 9.
Yeah. This is 4.
This is 4. And this is 3.
This is 3.
Then you put in a calculator, you multiply 6 times 9 times 4 times 3 is 648. You put in a calculator. I don't care the arithmetic part, it's not important. I
square
to the 4th power, right?
Yeah.
I to the 4th power. Hey, be quiet. I know that you know, but when I ask you, you participate, okay? I to the 4th power. Let me try to break it down like I squared times I squared, no? Because 2 plus 2 is 4, right? I know que I squared negative 1. Entonces, actually, this is negative 1. Multiplication by another negative 1 becomes positive. Wow, amazing. I to the 4th power is positive 1. And the answer is not 64, 648, I to the 4th power. No, it's just 648. Because this is positive 1. Now the conclusion is, well, we compute it separately, no? And normally you see in the problem, that kind of problem, by the way, in the test you see one problem. The number one question in the test look like similar to this. It's multiple square root. Inside we have negative number. And the student confusing this. I don't know why. You compute it separately. And after you try to investigate what happened with the power of the eye, gets the complicated part, but I want to explain in detail now. Look, in detail now. Any question, guy? Any question? Any question? Power of I
got it, mister.
Okay, you got it right. Power of I. Now, I want to generalize I to the whatever power, no? I know that I to the 1 is I. I know that I to the second is negative 1. I know that I to the cubic is negative I. Y I know that I to the 4 is positive 1. Okay, this is imaginary, this is real, this is imaginary, and this is real. And this pattern continues forever, 4 by 4. Let me show you. Suppose I to the 5th power. Okay, in my mind, I to the 5th power. I break it down like I to the 4th power times I to the 1 power, no? Because 4 plus 1 is 5, no? But I know that I to the 4 is positive 1, and positive 1 is invisible multiplier. So 1 times I is just I. Wow, amazing. So this is exactly the same of this in this row. I to the 6, repetition, negative 1. I to the 7, repetition, minus I. I to the 8, repetition, positive 1. Suppose another column. I to the 9 is high. I to the 10 is negative 1. I to the 11 power is negative I. I to the 12 is 1. And this continues, bang, 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 forever. Okay, so I try to find the formula. What is the formula? What is the procedure? What is the shortcut? What is the approach to find any power of I? Well, okay, I want to explain my way. Suppose I want to compute I to the 15 power. 15. Okay, we continue the table, but suppose I put a 45, this is too long table. It's crazy doing that way. So what is the idea? You try, I see, wow, look at that. The most important thing is any multiple of 4, any exact multiple of 4, like a 4, like a 8, like a 12, I suppose 16, no? is 1. 20 is 1. 24 is 1. Any exact multiple of 4 is 1. And 1 is invisible. So you break it down 15 using the multiple of 4 close to 15, pero down. In this case, 12. 16 is close, pero es up. So to avoid negative exponent, no good. I want down. That's less than. And I to the third power. Okay, I break it down 15 like a 12 and 3. 12 plus 3 is 15. Yeah, I know that this guy is 1. Look at that. Is 1. Therefore, the answer is I cubed. But I know, according to the first column, it's the most important column, que I cubed is negative I. And this is the final answer. And this is the final answer. Another approach I like so much. Another approach I like so much. You take the exponent, que es 15. Let's do the same example, but using another way, que in my opinion is better. You divide it by hand, no calculator, by 4. Why by 4? Because this part is repeated 4 by 4. 4 by 4, 4 by 4. Okay, entonces 4 by 4 es obvio que es 3. 3 times 4 is 12. Subtraction, typical division by hand. The remainder is 3. Entonces we have this answer 3 here, and we have this answer que 3. It's the same. Let me try to interpret what means that 3. For example, let me try to do. This is the column 0. This is the column 1. This is the column 2. The column 3 is I to the 13, no? I to the 14, que es negative 1, y I to the 15, que es negative I, no? It's a negative 1 and negative I. So the problem that we are solving is this. Okay, we expanded the table to reach that. But the meaning of these 3 indicate the column. You are in the column number 3. But I don't care the column. I care the position inside the column. The position number 3, this is the position 1, this is the position 2, and this is the position 3. The position 3 is I cubic. So you replace this immediately. I forgot this. I ignore this because this is this information. You put I to the cubic. Yeah, I know, okay, I cube, but to the cube is I. In my opinion, this is the best way. What do you think? Do you like that way or you like that way?
The second one.
The second one. Okay. Let's practice. Suppose I to the 18 power. Okay, so the second, we are using the second. You divide 18 divided by 4 by hand. Es obvio que 4, no? Because 5 is too much. Entonces 4 times 4 is 16, remainder 2. Entonces this is equivalent to say I to the second power, que es the remainder, y I to the second power, I know que es negative 1. This is the final answer. Suppose I to the 20.
That one's so easy.
Absolutely easy. Absolutely. I explained everything clear, guys. So you pay attention, and you have no doubt, you have no problem. You have doubt, yeah, ask me a question. Okay, I to the 20. Well, I have no idea. 20 by 4 is fine. No? It's 20, subtract 0 remainder. Wow. I to the 0, the power of the exponent is 0. I to the 0 is 1 because you need to know that any number or expression in algebra raised to the 0 power by definition is 1. But it's logical because 20 is exact multiple of 4. Look at that. 20 is 1. Look at that. It's exact multiple of 4. It's expecting that this situation happen. Okay. One more. I to the 9 power. Well, 9 divided by 4 is 2, 8. Remainder 1 is just I. That's it. Let me see in the picture. Oh, yes, look at that. I to the 9 power is I. We have more example? No more example. Clear? You need another example extra or no?
No, I got
No,
it.
sure. Okay, super.
Okay.
For example, I do the 45 power. What should I do? 45 divided by what?
By 4.
By 4. So 1, 4, subtracting is 0, bring down 5, is 1 again, no? 4, remain a 1. Okay. Entonces, I to the what power? 11 or 1? Huh? Just I to the 1 power, get this remainder. But you always using the remainder. I don't care the quotient number. The quotient number indicate me in what group this problem lie. But the important is the position inside the group. Get the remainder. Any question? No? I promise I want to complicate a little bit more this. But no. Remember, today is the day of the complex number. Well, professor, you talk about complex number. But so far, the only thing we see is imaginary number. Entonces, what about complex number? Well, complex number is the combination. Complex number is a combination. For example, suppose we have this number, 4 plus 3i. Okay, this is a complex number. Because it's formed by one part is a real part, and one part is pure imaginary. This is the imaginary part. Okay? And the combination, linear combination, real and imaginary, together is called a complex. Okay? Suppose the pure real number is 4, 5. No? We have no imaginary, 0. This is missing. That is the reason that not necessary to write this. This is stupid I. The pure imaginary number is I, 2i, 3i, no? Positive, negative, doesn't matter. Entonces, I omit the real part que I suppose que es 0. For example, I is 0 plus I. 0 plus 2i. 0 plus 3i. Suppose minus 4i. 0 minus 4i. Not necessary to write that part. Entonces, you suppose que es pure imaginary number. But the combination, real and imaginary, is called a complex number, right? This is one of the most important operations, arithmetic operation now, with the complex number. Well, the first one is conjugate. Extremely important. Okay, and the notation that we are using for the conjugate is, suppose the same example, 4 plus 3i. And you copy this bar to indicate hot, conjugate is hot. It's basically the same complex number, but you change the sign of the imaginary part, minus 3i. Okay, the conjugate is a family of the original. It's not twin brother. It's like a husband and a wife. Okay, suppose another example, 5 minus, suppose minus, to generalize that. Suppose minus 2i. And the conjugate is 5 plus 2i. Okay, do you understand very well conjugate? And we are using, I promise, in your moment, a conjugate of any complex number. Okay, now let's see addition, subtraction, multiplication, and division complex number. Okay, addition is super easy. Addition is super easy. Okay, let me try one example. Suppose addition example is 4 plus 3i plus 2 minus I. Addition. Okay, you remove the parentheses. 4 plus 3i plus 2 minus I. And we combine later. So you combine real part, 6. Imaginary part, 3 minus 1 is 2. End the story. Addition. Super easy. Subtraction. A little bit more complicated. It's similar. But you have, for example, the same number minus. You remove the parentheses. So the minuend stay the same, 4 plus 3i. But the subtrahend, no, change the sign because we have minus here. It's minus 2 plus I. I'm not ready to combine later. 4 minus 2 is 2, and 3i, and 1i is 4i. Balance. Any question, guys?
Yes.
No problem. Multiplication. Multiplication. You have question or no?
Yes, I have a question.
Please, go ahead.
Going back on conjugate. So basically what you're doing is you just switching
wait for me. You see conjugate and division. In division, you see the application for the conjugate, okay? But you ask me the idea, no? What is the idea for the conjugate? Come on, repeat the question, please. Sorry, I interrupt you.
Yeah, I'm just wondering. It looks like all you're doing is you pretty much switching the
yes,
the
yes. It's opposite sign only in the imaginary part. Opposite sign only in the imaginary part. The real part stays the same.
Okay.
Super.
Got it. Thank you.
Now let's do multiplication. Pay attention. Multiplication is no big deal, but it's a little bit weird. We know have some tricky part. 4 plus 3i times 2 minus I. We continue the same number, right? It doesn't matter what is the number. So basically, this is the multiplication in algebra like a two binomial. Entonces you apply the famous FOIL. Okay, you multiply. First, 4 times 2, 8. Outer, 4 times negative I is minus. Inner, 3i times 2 is 6i. And last is 3i times minus I is minus 3i squared. Okay? Apply FOIL. The classical FOIL. But one more time, you see, wow, you realize I squared, remember, it's negative 1. I know, okay, I squared is negative 1. So in this next line, you write a minus 4i plus 6i plus 3. Why plus 3? Because negative 1 and another negative 1 that we have in the front in this example. Another no, but in this example, become positive, no? Now ready to combine. 6 and 3 is 11. An imaginary part. Negative 4 and 6 is plus 2i. Final answer. Do you understand very well multiplication? So always in multiplication, in one moment of the multiplication, you need to replace I squared for negative 1. So you leave it like that. This is no wrong, but it's incomplete. Okay, entonces, so you express the answer using I squared, no credit. Okay, then one special, super special important multiplication is when you multiply any number, suppose the same, time is conjugate. Wow, look at that, is conjugate. Now you multiply this times this. You recognize that they are family. Okay, this is the complex number. Okay, this is this conjugate. Okay, I have no idea. I try to use some FOIL again. Why not? Okay, but you discover one surprise, two surprise. Okay, 4 times 4. Maria Curbelo, take a picture. She take a picture. Remember, Maria, this is recorded. I posted this video in Blackboard. 4 times 4, 16. 4 times 3i is minus 12. Alicia Figueroa. Minus 12i. Okay. Okay, guys, I am teaching now. I don't want interruption. Okay, we have problem. after you stay, any problem, you stay after the class or you email me particular in person, one by one. So say 4 times -3 is -12i. Let me see if I do it okay or no. Now again, multiplication 3i times 4 is positive 12i. Finally, this is minus 9. 2 times 3 is 9, no? I squared. So two things happen in this moment. Well, the same thing, okay, I squared is -1 and double negative become positive. And another thing is this and this is cancelled. And always this happening when you multiply any complex number times its conjugate. The imaginary part is gone, disappear. And we have 16 plus 9. Because double negative, no? Become positive. And this is 25. Wow, amazing. Okay, one fantastic conclusion. Look at that. Let me try to condense this information, and I want to try to explain a shortcut to do fast. When you multiply any complex number times its conjugate, number one, the answer we expect always is real. The I disappear. And number two is the multiplication. The answer is the multiplication. First, okay, 4 times 4, 16. Last, 3 times 3, without I and without minus. And you put always plus, the 25. This is a shortcut. Now the shortcut is, in general, let me put it in general. Suppose that we have one complex number, I plus IB, times its conjugate, is AI minus IB. The answer is, the formula is A squared plus B squared. Welcome from this. A squared is the multiplication A times A, and B squared is the multiplication B and B. And forgot the negative, and forgot the I. The answer is real, always. This is the formula, guys. Okay, suppose that you don't remember the formula, okay? Some students don't like to remember formula. So you are doing, again, like a kindergarten guy using FOIL, and you get right answer. I recommend you. But in some specific example, to do fast, I highly recommend doing by the shortcut. Let me see if you understand or you don't understand. Suppose that I multiply 2 plus I times 2 minus I. Help me, guys, what is the answer of this? But quickly, using the shortcut. Come on, what is the answer of this? 5. Sachari Fundora say 5. Everyone is agree get 5 or disagree?
Yeah, it's fine.
Absolutely.
No,
because 2 times 2 is 4. 2 times 2 is 4. The coefficients here, down. Is 1, invisible 1. If 1 times 1 is 1, and always plus, the answer is 5. Okay. Some students that don't see very well this idea, okay, no problem. Let's do it in the traditional way. 2 plus I, times 2 plus I, 2 times 2 is 4, 2 times I is 2I, 2 times I is, sorry, this is minus, carajo, this is minus here, plus 2I is a conjugate, no? This is not twin brother, and minus I squared. This is cancelled, so you see, okay, this is a special product in which the imaginary part always is cancelled. The answer never contains I, it's real. And you replace, remember, negative I squared is positive 1, no? Because I squared is negative 1. We have double minus. This minus and this minus together become positive. And the answer is 5. Suppose another 1 plus I times 1 minus I. What is the answer of this? Come on. No, Sachari, another participation. 2, very well. Oh no, Sachari again. It's 2, because 1 times 1 is 1, and 1 times 1 is another 1, and always plus. Unbelievable, but it's true. Always plus. The answer is 2. Okay, another, but not Sachari. Another participation. Sorry, okay. Sachari is sorry. Okay, suppose 1 minus 3i times 1 plus 3i. So you realize, wow, the problem that the professor put on now is multiplication to conjugate complex number. So he teach me the shortcut to do fast. Therefore, I apply the shortcut. I try. The shortcut is multiplication the first, last. What's the answer, guys? 10. Alicia Figueroa. Alicia Figueroa say que the answer is 10. Everyone is agree? Where come from this 10? 1 times 1 is 1. 3 times 3 is 9. And always plus. Unbelievable plus. And 1 plus 9 is 10. Done. Any question?
No.
No? Sure?
I'm pretty sure.
Okay.
You already probably explained this, but why is it plus?
The reason que es plus is because you remember that we have double negative means. Look in any example, in the last moment, we have this negative 1 because I squared is negative 1, and we have negative here. Double negative become positive. In general, let me try. Suppose miss. Who asked me? Introduce your name.
Oh, I'm Maria Carvello. Sorry.
Okay. Suppose A plus IB times A minus a B. It's two completely arbitrary A and B, I don't know, complex number. And you are doing 4 is I squared. This is minus ABI in alphabetic order, I put in alphabetic order. Plus ABI. The last is minus, because positive and negative together is I squared B squared, no? Because B times B is B squared. You know very well that this guy is gone, always. Therefore, the answer is just a number. 2, 10, 5. So the answer is A squared minus I squared B squared. And you know that I squared is negative 1. So it's I squared minus 1 B squared. Double minus become positive. Because I know this fact. I don't want to waste the time. I put always plus, positive. Because I know this fact. So basically, you multiply the first and the first. Okay, it's twin brother, no? A squared. And the last without I, and always put positive. End the story. No more complication. ¿Es okay, miss?
I got it. Thank you.
Eso, bueno. Okay, guys, let me try to explain division. Division. And division we need to use in this idea. Division. Now we study addition, subtraction, multiplication, now division. Division to complex number. Suppose 4 plus 3i divided by another complex number, 2 minus I. Okay? So we have always one systematic, traditional procedure. Okay, always it's the same. To simplification this division, you multiply this division by one thing I call one smart one. A smart one is when you have any number divided by itself as 1. And you know that 1 is invisible multiplier. Because you multiply by a smart one, doesn't affect the original problem. Therefore, the smart one you select using the conjugate of the complex number in the denominator, que es 2 plus I. 2 plus I. Okay? Do you follow me? That always is the same. You take a look, the complex number in the denominator, you copy the conjugate of this, and you multiply and divide by this. Let's do it. Multiplication, the top part. Multiplication, the top part is 4 times 2, 4. You foil. This is classical foil because they are no family. So it's 8. 4 times I, 4I. 3I times 2, 6I. And 3I times I is plus 3I squared. This is the classical multiplication, like I did before. Entonces, we combine later. Is, well, no, wait. In the next line, you replace I squared for -1, entonces -3. Remember, this is equivalent, -1, negative and positive, is negative in this case. And you combine this and this together, Fi, and this together, is 10. Okay, and this was the answer, and only the top part. Numerator and denominator now. Denominator is easy because denominator is multiplication, two complex numbers that they are conjugate. And we create the shortcut we did before. The answer is 5. Yes, you remember the answer is 5? 2 times 2, 4. 1 times 1 is 1 plus is 5. Do you remember or you don't remember?
I do remember.
Hey, you don't or you remember? You do remember. Okay,
do.
Sorry, I understand. Okay. Leave it like that. No. Why no? Because let me try to explain this idea. The answer of any operation using complex number, you express it always in a standard form. A standard means real part and imaginary part separately, right? So I highly recommend split this common denominator like that. 5 divided by 5 plus 10i divided by 5. So because 5 divided by 5 is 1, and 10i divided by 5 is 2i. Wow, elegant, super fantastic, final answer, division problem. Okay, to summarize, we have 2 more examples, don't worry. When you are doing division, always you create the smart one. The smart one is formed by the conjugate of the complex number in the denominator. And you foil the top part and you foil the bottom part. And not necessarily foil the bottom part because it's a special multiplication and you apply the shortcut. Okay? One more example. See, you have no question, no? 10 over 1 plus 3i. What should I do? Suppose in the test I put something like that. Division 10, 10 is a real number. It's a pure real number. Divided by conjugate, not by complex number, get 1 plus 3i. What should I do? Immediately, you multiply by the smart one. How you form the smart one?
It's going to be the conjugate of the denominator.
More
Which
specific.
is 1 negative 3i.
Eso. Mucho bueno. Okay. Let's do in the top part. The top part is easy because 10 is monomial and you multiply like a distributive property like that. Not necessarily 4. That's 10 minus 30i. And what is the answer in the bottom part? 1 plus 3i times 1 minus 3i. You foil or you apply the shortcut? Come on.
Shortcut.
What is the answer? You multiply. Real part.
4.
No.
-5.
No.
Oh.
10.
10. Fundora, Sachari Fundora. We did before. 10. 1 times 1 is 1. Always plus 3 times 3 is 9. It's 10. It's 10. The answer is just 10. Real number. No I anymore. And now you split 10 divided by 10 minus 30i divided by 10. The answer is 1 minus 3i. Wow, amazing. Easy. Any question? Any question? I understand very well. At the beginning, you don't see very well the shortcut. We have to practice. Okay, one more example. A little bit complicated. 8 plus 4i divided by 6 minus 9i. What should I do? Guide me. Help me.
You gotta find a conjugate of 6 negative 9i.
Is the conjugate you say is 6 plus or minus?
Plus, no, plus.
Es plus, es plus. Perfect. Okay. After the long process, multiplication, this and this, FOIL. FOIL this, top part. And bottom part, denominator part is shortcut, no? Bueno, okay. This is 48. This is 72. I. This is 24. I. This is 36. I squared. I finished, no. We continue a little bit. Remember, replace I squared for -1. My way, I know that this situation happen anytime. So, my way is you delete this, delete that, automatically I put -1 here. It's good or not for you? Or you want to do it step by step? Because I know that automatically I square is -1. So I delete I square, I put -1. See, we have double negatives have become positive, but in this case we have only one. Look at that. We have only one. Okay? Entonces es, in my mind, working in that way. I know que I square is -1. Boom. Delete. I put a minus. Delete. It's good or no? Do you like? Do you like or no?
Yeah, I like it.
I like. Okay, entonces in the bottom part. Well, no, let me finish the top part. The top part is you combine like term. You adding 48 minus 36. Es 12, no? Es 12, yeah. Es 12. Es 12. No, this color, no, I don't like this color. 72 and 24 is
96.
6.
96. 96, no? 96. 96. I know. Divided by, I don't know. I have no idea. Divided by what? Okay, but let's do in the who help me with doing the denominator part? Is using shortcut or apply FOIL again? FOIL again or shortcut?
No, shortcut.
Shortcut, okay. Shortcut is who helped me with the apply the shortcut?
Is it 15?
Is what? You
No,
multiply
I'll take
who?
it back now.
You multiply who? You multiply who? What guy you multiply?
So
The
6
6 and 6
and 9.
and 9i and 9i.
81, no? Something like that?
Yeah, that's
Yeah.
117.
117. Yeah.
Okay, leave it like that, no? You split 12 over 117 plus 96i 117. And now you reduce in lowest term In this case, you can divide it by 3, I suppose, in the real part. This is 4 over 39. In this case, you divide by 3 again here. Is 32i over 39. So always keep in mind this guy. You leave it like that. And my test on paper is okay. But in Alex, no. Alex don't understand that this answer is correct. You need to reduce and lower always. And this is super easy doing in the calculator. I don't know exactly what calculator you have, but if you put in a calculator like a fraction, you automatically, the calculator reduce the answer in lowest term. Okay? Okay. Okay. Let me, so far everyone follow me. You are okay. I am doing too fast. No?
No, Mr. I'm strong.
I know that you are. Okay. Let me try to come back again to the power of I. And you say, well, again, power of I. But in this case, power of I, we're using negative exponent. So with negative exponent. And this introduces a new complication. Suppose that I want to compare I to the minus 9. Wow, what the hell is that? I to the negative 9. And remember, do you remember what means negative exponent? Means?
Oh, 1 over something?
Exactly. 1 over something. So 1 over I to the 9. I to the 9 is piece of k. Divided by 4 is 2. A remain the 1. So actually, this is I to the 9 is just I. And leave it like that, or you need to continue working. So at this moment, the answer is 1 in the top reciprocal. Yeah, I discovered that I to the 9 was just I, no? Leave it like that, or we continue working. Continue or stop? No, continue, because you need to express the answer in a standard form. You need to express the answer in a standard, gets real part, plus or minus, depending on the problem, imaginary part. And this is the division problem. Hey, it's a water. Putting off the microphone, please. Oh, let me see who is it. Alicia. I don't know who is come from this word. Yeah. Cristian, Juan. Guy, what happened? Okay, entonces in this moment we have division problem. And what should I do in division problem? What is the idea for the division? Create the smart one, no? And the smart one is formed by the conjugate of the complex number in the denominator. What is the conjugate of the complex number in the denominator? What is the conjugate of I? Negative. Negative I, because I in my mind, look, I in my mind is 1. 1, no, sorry. It's 0 plus I. 1 I. So we have no real part. We have only one unit of the imaginary part. And the conjugate of this is 0 minus I. 1 I. So it's minus I minus I. Do you see this? Let me try to enclose in the blue color. This was my smart one. Everyone saw that or no? Let's do a multiplication. Multiplication at the top is negative I. Multiplication at the bottom is minus I squared. Because I, double I, and minus here gets this minus. And I know I squared is negative 1. So we have negative I in the top, and we have a negative 1. Double negative, become positive. Then we have in the top negative I, at the bottom we have 1. And 1 is invisible. And the answer is negative I, end the story. Any question, guys? Exponent negative. Introduce a new complication. Flip it, step 1, and now we create the division problem. Let's practice 2 more examples. Suppose I raised to the negative 13 power is 1 over I to the 13 power. 13 divided by 4 is 312. Remaining 1. It's 1 over I. Wow, it's exactly the same as this problem. I skipped that part because I did before. The answer is I. It's minus I, no? It's minus I. It's minus I. The answer is negative. Negative. One more. I to the negative 11. You there to help me or no? What should I do? What should I do?
Oh,
Convert.
1
Oh,
over I11.
Eso. 11 divided by 4 is 2, no?
Mm-hmm.
8 subtracting 3 is I cubic. 1 over I cubic. But I cubic, I know que es negative I. So the 1 over minus I. Now the conjugate, the smart one in this case is I positive, I positive. This is a smart one. So this is I in the top. And I know this product, the answer is 1. I did before. So negative I times positive I is negative I squared in negative 1 and negative 1 together is positive 1. This one is this one. And the answer is just I. Easy or no? No? Complicated?
Mm-mm.
Okay, guys, I know that you understand. But this is not the issue. The issue is you understand, but you try to study. Entonces, I created homework specifically for you. When you face directly by yourself with this kind of problem, entonces this is the crucial moment. Okay, guys, we have now another operation with the complex number. Today is the day of the complex number, I suppose. Suppose can we multiply? Multiply? No. Power. The power of the complex number. Power of complex number. O sea, exponent. Pero complex number. Suppose this elementary example, 2 plus 3i square. Well, si es square is easy. Si es cubic, no. It's complicated. 4, more complicated. So basically, you multiply 2 plus 3i times 7. In this case, they are exactly twin, brother. No conjugate. Conjugate is a family. And when it's a family conjugate, you have a special shortcut. But in this case, no. We have no special shortcut, and you apply 4. 2 times 2, 4. 2 times 3i, 6i. 3i times 2, 6i again. And 3i times 3i is, you know, it's 9i squared. But I know if this situation happens, always I put directly minus 9. Do you like this way?
yeah.
Me
Yeah.
too. I love you.
Yeah.
Now we combine real part. 4 and negative 9 and negative 5. And 6 plus 6 is 12. End the story. Let me complicate a little bit your life. This is weird example. Look. Radical 2 over 2 plus I radical 2 over 2 squared. Wow, professor, what is the reason that you put this weird number? This is irrational number. And always is happy if we have a rational number, fraction, or whole numbers. In this case, we have irrational, irrational, irrational. No, it's real. Actually, the rational numbers belong to the real number. Okay. I have no idea. I separate like that. Radical 2 over 2 plus I, radical 2 over 2 times itself. Okay, and you fall. Radical 2 over 2. Let me copy here separately because it's the same calculation. Repeat it 4 times. Because I want to copy here. Radical 2 over 2 times radical 2 over 2. Who helped me to compute that? Using your knowledge of the radical and multiplication, top, bottom. So multiplication top. Radical 2 and radical 2 together is, help me. Es tú, Sachari Fundora. Sachari, you are good. And 2 times 2 is 4, no? 2 times 2 is 4. Radical 2, everyone is agree que radical 2 times radical 2 is 2. And
Yeah.
this is 2 over 4 is 1/2. So the answer is 1/2. Look, when you multiply this guy times this guy, I did in the one corner of the piece of paper, like an auxiliary calculation, the answer was 1/2. When you multiply this times this, I suppose the answer is the same, except that we have one I. So it's plus 1/2 I. When you multiply inner, this guy times this guy, it's exactly the same, 1/2 I. And when you multiply the last case, this times this is 1/2 again, no? But it's -1. So it's negative, right? Because remember, I times I is I squared. Do you see that or no? Well, let me try to fix a little bit that part. Minus 1/2. Make sense or no? No?
Yeah.
Yes.
Okay. Now ready to combine lighter. What happened with the real part? What happened with the real part? Positive 1/2 and negative 1/2. Wow, it's canceled. Delete. And we combine positive 1/2, another positive 1/2, 1/2 plus 1/2 is 1, no? So what is the final answer?
Two.
1/2 I plus another 1/2 I. What's the answer?
1 I.
1
No.
I. Very well.
Oh.
The answer is just I or 1 I, whatever you want. You put 1 is okay, but normally this one is invisible, no? Okay. Unbelievable. The answer is just I.
Wow.
Okay. Wow. Too much work to get only 1 I, like a final answer. Okay, let's practice. Let's spend the rest of the time practice miscellaneous problem of the operation with the complex number. Okay, and I need help. Suppose this given information. If Z is equal, one complex number gets 3 minus 4i. And W is another complex number, que es A plus 3i. I need to compute several operations. I need to compute number one operation, C plus C conjugate. Number two, W minus W conjugate. Number three, C times C conjugate. And number four, C minus W conjugate. Okay, let's do it. Who is C? Bueno, C es 3 minus 4i. Entonces, basically, 3 minus 4i, I copy. I replace this C for this C, ¿no? And this is C conjugate, the conjugate of this is 3 plus 4i. Are you agree or disagree?
I agree.
I agree. So what is the answer of this? What is the answer of this? What happened with the imaginary part?
6.
Say again? What is the answer you say?
6.
6. You say que es 6. Because 4i positive and negative is cancelled, and 3 plus 3 is 6. Done. Let's do in the second. The second is W, or W is A plus 3i. Minus subtraction. Be careful. This was addition. Now subtraction. Subtraction what? The conjugate of W. The conjugate of W is A minus 3i. Intentionally, I put the parentheses because I know in the subtraction operation, you need to change the sign totally completed of the subtrahend complex number. Okay, remove the parenthesis. Remove the parenthesis is A plus 3i, I copy exactly the same, minus A plus 3i. Because this minus outside change the sign completed of the second complex number, right? So what is the final answer? What happened with the real part?
It cancels.
It's cancelled. And the imaginary part, 3i and 3i?
It becomes 6i.
6i.
Super. See, time. This is time. Multiplication. This is 3 plus or minus 4i. 3 plus 4i. We did before this example. What is the answer to this? Using the shortcut, quickly. The answer is real or is it more complex? 25. Sachari Undora. He said it's 25. Where I come from? 3 times 3 is 9. 4 times 4 is 16. Always plus 25. Any question? Okay, let's do in the last one. Z. Well, C is 3 minus 4i. Minus W. W is A plus 3i. And finally, you find the conjugate of this totally complex number. If you want to make easy, we can compute the part inside the heart, or ignore the heart, temporary. This minor effect become negative A and minus 3i. No? Entonces, ready to combine like term is 3 and negative A is negative 5 and 7 is 4 and 3 is negative 7. No? I. So far the answer is negative 5 minus 7i conjugate. Okay, this is the last operation of the conjugate. What should I do? What happened? What's going on here when you compute the conjugate of this complex number? What happened with the real part? Change or stay the same?
It stays the same.
It stays the same. And the imaginary part?
It changes.
It's changing very well. And this is the final answer. Also beautiful, fantastic. We are the best. Okay, we have one more operation of the complex number. The last one, I promise it's the last one of the complex number. Suppose this. Okay, open bracket, because it's complicated operation, parenthesis, 4 plus 2i, minus, parenthesis, 6 minus 4i, close the bracket, divided by something, divided by parenthesis, 2 plus 3i. According to the order of operations, what should I do first? Well, okay. When you have fractions, we can work totally independent. The top part. This is the advantage. I take advantage. You compute, you ignore temporary that part. But you ignore that part. Temporary, of course. And we compute that part. And finally, denominator part, you ignore that part. Okay? So we can work it separately if you want. Entonces, we focus in the top part. The top part is subtraction, no? Okay, entonces one corner of the piece of paper, auxiliary calculation es paréntesis 4 plus 2i minus paréntesis 6 minus 4i. Remove the parenthesis. It's 4 plus 2i, stay the same, minus 6 plus 4i. Correct? Change the sign of the subtract hand because we have a minus in the front. We combine like term here is 4 and negative 6 is negative 2. And 2i and 4i is positive 6i. Okay, this is the answer in the top. Minus 2 plus 6i. Good. Divided by 2 plus 3i. Oh, what should I do now? What should I do now? Division. Entonces, what's the procedure for the division? Always, it's the same.
Find the small one.
Exactly. You create the small one using the conjugate of the complex number in the denominator. In this case is
2 minus 3i.
2 minus 3i. 2 minus 3i. Okay, super. Now, in the top part, always you using FOIL. In the bottom part, you shortcut. Es minus 2 times positive 2 is negative 4. Minus 2 and minus 3i is 6i. This is 12i. And this is minus 18, no? 18i squared. Pero I know que I squared is negative 1. I replace by negative 1, entonces become positive. Divided by, who helped me with the bottom part? This and this. What's the answer of this? Shortcut.
It's 10.
Is what?
10?
What's the answer? In the
13.
denominator part.
No. It's
Come on. I need answer.
13.
13.
Eso, bueno. 13. Where come from 13? 2 times 2 is 4. 3 times 3 is 9. Always plus. Unbelievable, but it's true. And when you combine 4 plus 9, 13. Okay, ready. Almost ready to finish. Entonces es 18 and negative 4, que es el real part, es 14, ¿no? 14. 6i, 18, ¿no? Divided by 13. Okay. You can leave it at that, you can. But much better is expressing standard, que es 14 over 13. So you split this common denominator in two pieces. 18 over 13. Nice. More elegant way to express the finals. Any question? Good?
Strong, mister.
Strong, okay. Now we spend the 10 minutes that we have to recall quadratic equation. Guys, quadratic equation and college algebra is extremely important. We are using, I promise, that we are using every day quadratic equation and college algebra. Every day, quadratic equation. You see, today I try to recall a little bit quadratic equation. But I promise that the last day, December, the last problem that we are doing contains quadratic equation. We are solving another complicated thing, but in the last moment, we need to solve a quadratic equation. So quadratic equation is fundamental to understand. Okay, the quadratic equation you recognize because it's equation that contain exponent 2 mean quadratic. And the standard is ax squared plus bx plus c equal to 0. Okay? Sometimes happen. Okay, a, b, and c in general, a, comma, b, comma, c are in general real number. And sometimes it's missing, it's 0. The only guy gets impossible to be missing is a, because if a is missing, it's a linear equation, no quadratic equation, no? Therefore, it's important, A is fundamental to recognize. But when a B is missing, it sometimes happens that B is missing. Because the best way for solving this equation is using the square root method. Let's see some example of the square root. Is the shortcut to make easy the solution for the quadratic equation when there is B is 0. Suppose this example, x squared minus 4 equal to 0. My question is, this equation is example, let me call example 1. This equation is quadratic, yes or no? Yes, no. Yes or no? A
No.
quadratic equation, no? Yes?
It's missing the B.
Yes.
It's missing the B. Okay, I agree. The answer is yes, it's quadratic. A is 1, because the coefficient here is 1, invisible, no? B is 0, amazing, okay. And C is negative 4. Entonces, when the B is 0, important. The best way to solving this is solve for x squared and move 4 to the other side, apply a square root. This is the name of the method. And this is just x because the square root and the square power 2 cancels out each other. And the square root 4 is 2, but don't forget plus new idea. New idea. We have two solutions. Solution set is plus or minus 2 or 2 and negative 2 or negative 2 and 2. Regardless, it's not important. The order is not important. Or we can condense it using this symbol, plus or minus. Okay? This is the idea for the square root. Let's practice square root method. It's super easy, but super important. Example 2. Suppose x squared plus 9 equals 0. Who help me? Come on. What should I do? A quadratic equation, yes or no?
Yes.
B is missing, yes or no? B is missing, yes or no?
Yes.
Yes, Mr.
What is the best way to solve that? What is the best way? Square root, right?
Square root x squared.
You isolate square, x squared, you isolate, similar to the linear equation. You move 9 to the right-hand side like a minus 1, and you apply square root both sides. This is x. And what about square root negative 9, guy?
3i.
3i. Very well.
3i, Mister.
3i, mister? Okay, 3i. And don't forget plus or minus, because always we have two solutions, positive and negative. When you apply a square root, we have two solutions. Entonces, solution set plus or minus 3i. In this case, the solution are purely imaginary. In this case, the solution in the first example was purely real, plus or minus 2. In this case, plus or minus 3i. It's purely imaginary solutions. Okay. Okay. Example 3. Okay, this is x plus 9 squared plus 16 equal to 0. Okay, there are many ways to solving this problem. Okay, one student say, well, professor, you expand the part and determine A, B, and C. In this case, B is not missing. However, I recommend take advantage if somebody do the factorization of that part.
Mister, you square, right?
Exactly. And you consider that this is a square. So you isolate the part is a square. You move 16 to the right-hand side like a minus. You apply square root. Similar to the problem that we are doing before. This is x with a square root and a square, and this is 4i. Don't forget plus or minus. Finally, solve for x. X is equal to minus 9 plus or minus 4. Wow, and we have two solutions, but in this case, the solutions are complex. Solution is negative 9 plus or minus 4. If you want, you can write separately like that. Minus 9 plus 4i and minus 9 minus 4i. Separate by common. Excellent. Everyone follow me?
I follow you, mister.
Okay.
Yeah.
Good. I like this class. Pero guys, I promise I want to complicate a lot of this. Okay? This is called algebra. P plus 10 square equal to 100. Wow. What should I do for solving this? I take advantage the power 2 here or no?
Yes.
Yeah, of course. You apply
Yes.
square root cosine.
You square root.
So P plus 10, because you know que square and square root cancels out each other. In this case, you have plus and minus square root 200, but remember 200 is 2 and 10, and 100, sorry, and square root 110, because plus and minus 10, radical 2, no? And these two stay inside the radical, and this 100 no, this 100 go outside like a one thing. And so for P is equal to minus 10 plus and minus 10 radical 2. Okay, solution set is, you write like that, minus 10 plus and minus 10 radical 2. In this case, be careful. This is real, because I don't see any I here. It's not complex, it's real. But the problem is that it's irrational. So we have one part is rational and one part is irrational. And together it's irrational number. But it's okay, it's real, it's irrational. Okay? Okay. I suppose it's good. Well, we have 3 minutes. Okay, 3 minutes. In 3 minutes, I want to introduce. So the first method that we are using for solving quadratic equation is using the square root. And this is good only when the b is 0 or when somebody do the factorization, I take advantage of the square to apply square root both sides. But no situation. So now let's study in detail now solution of the quadratic equation by the completed square. By the completed square. Completed the square. Method. Okay, let me explain perfect first of all what is perfect. The square trinomial.
Mister, I have a question.
Please.
Mister, so the formula for complete the square is parenthesis b over 2 parenthesis square, right? Just to recap.
Yeah, approximately. Let me try to explain. Okay, first of all, I need to understand this. No, memorize the formula. What is perfect square trinomial? Suppose this trinomial, x squared plus 4x plus 4. Oh, a perfect square because the factor is, look. It's x is 2, because 2 times 2 is 4, and 2 plus 2 is 4, and plus both, no? Okay, by the way, this is equivalent to say x plus 2 squared, because they are twin brothers. Okay, when this situation happens, when the factorization because I know that the factorization, one trinomial is two binomial, but when these binomials are twin brother, it's the same, we condense it in only one and put a square. And this situation is perfect square trinomial. Suppose another example to understand more clear. Oh, in this case, the same, because the factorization is phi, no? Because 5 times 5 is 25, if 5 plus 5 is 10. In this case, minus both. The factorization is x minus 5. The idea for the complete square is enforcing the situation to be the trinomial perfect square. How you enforcing the situation to be perfect square? Well, let me try. Example 1 of the completed square. Suppose this example, x squared plus 4x plus 10 equal to 0. Okay, this is my quadratic equation get given in the test. I need to solve it. Be careful, guys. Important. I want to say this. This is very, very important. In the test, you can find only one question que solving the quadratic equation, but it's mandatory doing by completing the square. If you solve it another way, you get the correct answer, no credit. Like mandatory by completed square, only one question. And the rest of the quadratic equation in the test, number 1, is completely free. You apply the method that you consider best. But one question is mandatory by completed square. So what is the organization of the completed square? Well, I copy that. And this thing I move to the right-hand side. And here you write in this box a magic number that completes. I call magic number. Okay, and the formula for this magic number is b over 2a squared. Or another way is b squared over 4a squared. It's the same, no? But the shortcut, numerical is easy. You divide 4 mentally. 4 divided by 2. Always divided by 2. Look at that. Divided by 2. 4 divided by 2 is 2, no? And 2 squared,
Yeah.
F4. And you put 4 here and 4 here. And this is trinomial perfect square, exactly the same like in this example. And the factorization is x plus 2. Sorry, guys, the time is over. So you combine this part is minus 6, no? The rest is piece okay. You apply square root. We continue next time doing more examples of the completed square because it's important. And this is x plus 2 alone is equal plus and minus I radical 6. And 6 is impossible simplification more. And finally, I move this to the other side like a minus 2 plus or minus I radical 6. This is the elegant final answer in this problem. Next time we continue doing more quadratic equation. I am enjoy teaching you this class. I like this class. Okay. Some students can need to ask me something, stay. I want to drink some water immediately. I write back. The rest you can leave. Thank you. Pleasure.